Okay, so I had some technical difficulties. I actually had to stop the video instead of just pausing it. But hopefully you found your way back here to the next video. So here's number 3 all worked out. So we stopped at that line that said GCF. So from there, your GCF is 3. Pull that out, you get x squared plus 6x minus 27. And then you want to factor that. That's an easier trinomial. Two numbers that multiply to 27 and add up to 6 are 6 apart, are 9 and negative 3. Once you get to that solving, or to this factoring portion, you always want to kind of double check that it's correct. So just in your head, you can think x squared, 9x minus 3x, and then minus 27. Set each factor equal to 0. Now, even though we have 3 as a factor here, 3 can't be equal to 0, right? So sometimes I kind of write that just to remind myself, yes, I've looked at it, it can't be equal to 0. We'll see an example similar where we do have to work with it in a minute. So we get 2 answers, negative 9 and 3. Again, knowing this is a quadratic and x squared, it makes sense that I could have 2 answers. Okay, let's move on to the next part. So for this one, we have the left side is factored already, okay? However, so if this were equal to 0, if it were 7 minus 2x times 5 minus 2x equals 0, then we would be set and we could just set each factor equal to 0 and solve. However, it's not equal to 0, it's equal to 15. And so that product property doesn't work for anything other than 0 because just knowing that 2 numbers multiply to be 15 doesn't give me enough information. It could be 1 and 15, it could be 5 and 3, it could be 7.5 and 2, we don't know. So what I have to do here is I have to get this equal to 0. Okay, so if I do that by subtracting the 15, I still can't combine things because the other terms are within those binomials. So it's a little bit of extra work when you have something like this. So I'm going to distribute that left-hand side, okay? And then I'm going to move the 15, combine like terms, and then factor again, okay? And then I can keep solving. So let's take a look at this. I'm going to distribute this left-hand side first. So 7 times 5 is 35. 7 times negative 2 is negative 14x. Negative 2x times 5 is negative 10x. Plus 4x squared equals 15. Now I'm actually going to combine these two first just to clean it up a little bit. You can wait and do it afterwards either way, but 35 minus 24x plus 4x squared equals 15. This is more like what we would have started out with, kind of like we started out with last time. I want to make it equal to 0. Because my x squared, my highest exponent term, is already positive, I'm going to leave that on the side it's on. I'm going to move the 15 over. So I'm going to subtract 15 from both sides. 20 minus 24x plus 4x squared equals 0. I'm going to rewrite this in standard form. And now I'm going to factor. So I'm looking at, I can see I have a GCF. Okay, for any of these things that I do a little bit quickly, feel free to pause the video and kind of work through it in your head. Some of this, pulling out a GCF, I'm sure is getting more and more comfortable now, more familiar, but if you're still having some trouble with it, feel free to stop the video. And then if you can't figure it out, that's a good place to ask me, right? Okay, so now I look at what I have left after I pulled out the GCF, and I can factor that. X minus 5 and x minus 1. Okay, I need 2 numbers that multiply to 5. The only way to make 5 is 1 and 5. Because they're adding to a negative, it must mean that both of them are negative. So then again, 4 can't be my factor that equals 0, but x minus 5 could equal 0, or x minus 1 could equal 0. So I solve for both of those, and I get x equals 5, x equals 1. Those are my 2 answers. Again, any questions you have, look back over this part of the video and then, mark it down and ask me. Okay, so now we have one that looks a little crazier, right? So we have x to the fourth. So this is going to have up to 4 solutions possible. And again, whether the up to part, think about the graph. If one of those curves just touches the axis in one spot, that's different than going down and back up, right? Okay, so if we look at this, we want to bring everything to one side. So I'm going to subtract the 40x. And again, I'm just going to kind of put it over here because it's not a like term with anything else. So it's going to go on the end because it has the smallest exponent. And then I look and try to find a GCF next. So GCF for this, if I look at all those numbers and all those variables, the biggest thing I can take out is a 2. Okay, nothing else goes into all of those, and then an x also. So I take 2x out. I'm going to get 3x to the third plus 5x squared minus 12x minus 20. So I pulled out my GCF. Now what I have left is 4 terms still. So I'm going to go ahead and factor by grouping. So what I'm doing to the left side now is just like I would have with factoring, right, in chapter 9, just if it were not an equation. So I take 2x. I'm going to need the extra little bracket here when I do this part. First 2 terms for factoring by grouping, the greatest common factor of those 2 is x squared, and I have 3x plus 5 left. Remember, for these 2, because of that negative, I'll bring that down. 12x and 20, what they have in common is 4, and I have 3x plus 5 left. Negative 20 divided by negative 4 is positive 5. And then I can finish my factoring by grouping, saying 3x plus 5 times x squared minus 4. And now, remember in chapter 9 at the end when we talked about factoring strategies and looping back up to that second step as many times as we need, hopefully it jumps out at you that x squared minus 4 is the difference of perfect squares. So I can keep factoring. So I want to keep factoring until I have a linear equation all the way across, all linear factors here for our purposes. That's what we're going to do. Okay, so remember in the last one we said that first factor was 4 and that couldn't be 0, right? Well, in this case, our first factor, you can think of this together if you want, a couple ways to think about it, but our first factor is 2x. And 2x can be 0. So if it's just a number by itself, that can never be 0. But if it has an x in it anywhere, then that can be. So I am going to solve that, and x could be 0. That's one of the options. Or 3x plus 5 could be 0. Or x plus 2 could be 0. Or x minus 2 could be 0. So let me go ahead and solve each of these. Now this next one is the first case where our solution is not going to be an integer. And I can tell that because I'm going to subtract this negative 5, and then I'm going to divide both sides by 3. So x equals negative 5 over 3. X equals negative 2. X equals positive 2. So I do have 4 solutions in this case. 0, negative 5/3, negative 2, and positive 2. And I can go and check each one of those. You don't even have to do it by hand. You can put it in your calculator, right? 6 times negative 5/3 to the 4th plus 10 times negative 5/3 to the 3rd, etc. Okay, so I think we have one more. Yes. So again, let's go ahead and pause the video and see if you can go ahead and solve this one. Now, again, my trick, you don't have to, but I am going to add the 3x to the 3rd. I'm going to move everything to the left side because I want that x to the 3rd, my highest exponent, I want that to be positive. So I'm going to have 3x to the 3rd plus 6x squared minus 75x minus 150. Okay, so you want to look for a GCF first. Then you can tell you're going to have 4 terms, right? So maybe think about factoring by grouping. So go ahead and pause the video, and when you come back, it will be done. Okay, so you can see here my work. You can pause it if you'd like and check your work. So I pulled out a GCF of 3 first, and then I still had my 4 terms. Then I have 3 times, now I'm factoring by grouping, so I pulled an x squared out of the first 2 and a negative 25 out of the last 2. That gives me x plus 2 times x squared minus 25, very similar to the last one. Hopefully you noticed that difference of perfect squares. So I get 3 times x plus 2 times x plus 5 times x minus 5. So one of those factors, or any of those factors, could be 0, but not 3, right? So x plus 2, x plus 5, x minus 5. It makes sense anyway, because it's x to the third. It's a cubic. The cubic just means x to the third power, which means I can have up to 3 solutions. I couldn't have 4 anyway. Solve. My 3 solutions are going to be -2, -5, and +5. Okay, so that's our factoring, using factoring to solve the equations. Now we have another method to solving equations, and that is using the quadratic formula. And you may have heard about this before, or sometimes parts of it sound familiar. So when we were factoring, you saw that we factored things that were x to the third, x to the fourth, right? Well, this is just for quadratic equations. So I can only solve quadratic equations using this quadratic formula, okay? So my quadratic formula is this whole big thing right here. And you do not have to memorize it, okay? You can use your reference sheet, it's on there, you just have to know how to use it. So where does this nonsense all come from? Well, let's think back to something a little bit different for a minute. What if I have, we talked about this earlier in the semester, what if I have something like x plus 5, let's say 2x plus 5 equals 8. And I want to just solve it for x, right? And we did this, actually, let's do a little bit different. Let me back up a little here. What if I said 2x plus 5 equals y, right? And it's solved for y, but I want to solve it for x. I want to get x by itself. Well, I would subtract my 5 from both sides. I'd get 2x equals y minus 5. And I would divide by 2, and I'd get x equals y minus 5 over 2. Okay, and that kind of looks like a mess, but it's got an x all by itself. That's essentially what this is from. So we could have taken, and if we had more time, we were in class, we probably would, but we can take this, ax squared plus bx plus c, and solve for x. Move things around like we did over here so that x is all by itself. And if you do that, you will end up with this thing that looks like a big old mess. Okay. But that's where that came from. It didn't just get like created, it came from that. So this is how we find x, how we find the solutions for a quadratic equation. So notice that this is x equals blah, blah, blah. So our answers will be the answers. X equals 5, x equals 2, whatever it is that are our solutions. So when we solve using the quadratic formula, you can see that on the right-hand side, we have a, b, and c. Where do those come from? Well, they come from here, right? A is the number in front of the x squared, b is the number in front of the x, c is the constant that's all by itself. So that's where those come from. All right. So let's go ahead first and figure out what our A, B, and C are, and then it's just a matter of plugging in and really carefully working through that work. So in this case, I have A is whatever is in front of the x squared, okay? It's a 1. B is whatever is in front of the x. Watch your signs, it's -3, and C is -4. Now you might notice that in the quadratic formula, the very beginning of it on the right side has -b. So sometimes I like to write that out right from the beginning too. So if b is -3, then -b is the opposite of that, which is +3. Okay, so I'm going to write out the quadratic formula. I know it's right above there, but I think sometimes it helps to see it right next to what we're doing. Okay, notice that the entire top part, that whole part that you wrote, is all on top of the fraction. Sometimes people try putting the fraction only under one part or the other, but it's the whole thing. Okay, so we're going to start with x. X equals -b. Well, we know that since b is -3, negative b is positive 3. Then we have this thing that's a plus and a minus put together. And that's really just a shortcut, because at the end we're going to say, okay, what is it plus this? What is it minus this? It's two different problems written into one. Then we have the square root of b squared, negative 3. Make sure it's in parentheses. It's a really, really common mistake, and then it messes everything up. Minus 4 times 1, which is a, times negative 4, which is c. And then all of this, including that 3 out front, is 2 times over 2 times a. Okay, so now we're going to clean this up a little bit, right? We're going to simplify things. So we'll get 3, can't do anything with that yet. We can simplify in the square root. So negative 3 squared is going to be 9. Negative 4 times 1 times negative 4 is positive 16. And then on the bottom we have 2. And then let's keep going, simplifying under the square root. 9 plus 16 is 25. Now, we don't always get a perfect square here, okay? I'll talk about that in a second. But in this case, we did. So 3 plus and minus the square root of 25 is 5. Now, because we had a perfect square here, and we have just an integer here now, where the radical 25 was, I can just go ahead and I'm going to split this up into two problems. 3 plus 5 over 2, which means 8 over 2, which means 4. I'm running out of room a little bit here. Or 3 minus 5 over 2, which is negative 2 over 2, which equals negative 1. Okay, so those are our two answers. Okay, so what we have for our solutions are x equals 4 and x equals negative 1. Okay, now any quadratic equation can be solved with a quadratic formula. Let me say that. You might also be able to factor it. So I don't really care. If it's something that is factorable, you can do it either way. Okay, but sometimes we have something that's not factorable. You can still do it using the quadratic formula. Now, sometimes you may end up with an answer that doesn't look as nice as this. Let's say we end up with x equals 2 plus and minus. Let's say we get radical 11 in here. Okay, well, 11 is not a perfect square, so I can't do anything with it, so you're just going to leave it like that. You're not going to, if you put radical 11 in your calculator, it's a decimal, but we know it's an irrational decimal. It goes on forever. So it would just be your approximation. So unless you need to do something with it, like graph it, which you won't have to in this class, just leave it like that if you see one that's not a perfect square. And those would be your two answers. Okay, so we have, let's see, 3 more problems like this. So why don't you go ahead and pause the video and try them, and then come back and check your answers. So you're going to set it equal to 0 first, then find A, B, and C, then substitute in. Okay, so here is number 2, and again, you can kind of pause the video as you need more time to look at it. You have to get it equal to 0, so I moved things around, wrote out my A, B, and C. I kind of like to write out the negative B right from the beginning also, so that reminds me about that. I substituted in. If you have a different answer here, watch your signs. That's probably the situation that's giving you trouble. Radical 324 is a perfect square nicely. It's 18. So then I just ran out of space. So I moved over here with my plus and my minus options. And so my two solutions are 3 and 9. All right, for number 3, move the 8x over, set it equal to 0, have my A, B, negative B, and C substituted in. Now in this case, I get 0 under my square root. The square root of 0 is 0. What that means is that negative 8 plus 0 or negative 8 minus 0 doesn't change anything, so I really only have one option. I only have one solution. If you think about how you would, this one is factorable, so if you think about how you would factor it, x squared plus 8x plus 16, two numbers that multiply to 16 and add to 8 is going to be 4 and 4. So again, this is a situation where you'd have the same factor twice, so you're really only ending up with one answer, right? And if we think about the graph, it would be hitting the graph in just that one spot. Okay. So again, if it's not, there's nothing special about why we're doing this one by quadratic formula. Okay, only because I said to, because it's in this part of the notes. Otherwise, if it's factorable and it's quadratic, you can use either method. If it's not factorable, you can always use the quadratic formula. And if it's not a quadratic, if it's an x to the third or higher, you need to use another method. The one we know right now is factoring. Okay, the last one. Now again, this is not equal to 0. I can't just pull the 60 over because it wouldn't get like absorbed into that, the rest of those numbers, those expressions. So I have to distribute first. I combined like terms. I distributed the 2. So I have to get everything out of parentheses if I want to combine like terms. Move the 60 over. Now, at this point, you could pull out a GCF and factor, right, in this case, or in this, because we're practicing quadratic formula, I wrote out my a, b, and c, my negative b plugged in. Luckily, again, we got a perfect square under the square root. 18 plus 22 over 4, so we have 10, and then 18 minus 22 over 4 gives us negative 1. Okay, and the last question here, I think I just have one of these, yeah. I just wanted to kind of show you solving the same thing all three ways, right? To show you how they all go together. If it's one that can be done both ways, you're going to get the same answers, obviously. So if I solve by factoring, I would need two numbers that multiply to negative 6 and add to negative 1. Okay, so if I think about 6, I want it to be negative. I'm going to have the larger of each pair be negative. I get 2 and negative 3. So I'm going to get x minus 3 and x plus 2 equals 0. I set each one of these equal to 0. So this, I add 3 to both sides. Really didn't leave myself enough space here. X equals 3. Subtract 2 from both sides. X is going to equal negative 2. Okay, so go ahead and try the quadratic formula. I'm going to do it through as a whole problem, but if you pause now, you can try it first and then come back and we will go through it together. I'm just going to write it here. You can go ahead and pause and try that, please. Okay, so hopefully you took a minute to do that. My quadratic formula, I need a, b, and c. So a is 1, b is negative 1, c is negative 6. Negative b is going to be positive 1, the opposite of what b is. So x equals, okay, and again, you'd have the quadratic formula in front of you at your reference table. So let me just write it here. Okay, so negative b is 1 plus and minus negative 1 squared minus 4 times 1 times negative 6, 4 times a times c. The entire thing over 2 times a. So we can start by simplifying what's in the square root. So negative 1 times negative 1 is 1 plus 24 over 2. This can equal 1 plus and minus radical 25 over 2. 1 plus and minus 5 over 2. So 1 plus 5 over 2 is 3. 1 minus 5 over 2 is negative 2. 3 and negative 2, again, the same answers. And finally, if we solve by graphing, remember from chapter 5 when we're graphing quadratic equations, the way that we know how to do it right now is with a table of values. So I can plug some ideas in for x. I can have a little workspace and I can find out what y would be. So if my x, let's go from negative 3 to positive 3. Okay, so negative 3 squared minus negative 3 minus 6. Watch your signs there, okay? I'm actually going to take this out and extend this a little to give myself a little more room. Okay, so this is going to give me 9 plus 3 minus 6. 12 minus 6 is 6. And I have negative 2 squared minus negative 2 minus 6. 4 plus 4 minus 6. 8 minus 6 is 2. Then I do negative 1 squared minus negative 1 minus 6 equals 1 plus 1 minus 6. So 2 minus 6 is negative 4. You know what? Hopefully you caught my mistake before I did. This should be 4 plus 2, which is 6. 6 minus 6 is 0. Sorry about that. Okay, 0 squared minus 0 minus 6. 0 minus 0 minus 6 is just going to be negative 6. 1 squared minus 1 minus 6. 1 minus 1 is 0. 0 minus 6 is negative 6. 2 squared minus 2 minus 6 is 4 minus 2 minus 6. 4 minus 2 is 2. 2 minus 6 is negative 4. 3 squared minus 3 minus 6 is 9 minus 3 minus 6. 9 minus 3 is 6. 6 minus 6 is 0. So if I go over here and graph these, and again, it's a little tricky for me to draw in a nice axis with this little tablet, but we'll do our best here. Okay, and then I'm going to label and go into the negatives on both sides. Oops. So I'll just do every other one. Okay, so negative 3, 6. It's a little bit thicker. So negative 3, 6. Negative 2, 0. Negative 1, negative 4. 0, negative 6. 1, negative 6. 2, negative 4. 3, 0. Okay, so couple things about this. First of all, we see that it looks like a parabola, so that's good. You know it should be a parabola when you're graphing. If you make a mistake and it looks like an S or something, then you know that's a good indication to go back and figure out what you did wrong. Also, remember a parabola is a U, so if you look down here, it looks like these two bottom points, like it would make a straight across point. Really what's happening here is if I found out the Y value for X being 1/2, it would be down here somewhere, right? So just, it doesn't have to be exact, but just go through that knowing that's going to be a U, not flat on the bottom. And I bet you can guess what 4 would be. If I did 4, it's going to be symmetrical to negative 3, right? So now I just go ahead and whoa, that is not a good example. I go ahead and draw my line through there. Okay, is a little tricky on here. Oh my goodness. Anyway, draw a nice little line. It is kind of tricky sometimes, even on paper. Really having trouble on here today, but we'll get an approximation. And then remember that we're looking for the solutions when we graph. Where are my solutions? They're where it crosses the x-axis, which is at, we have to write them out too, x equals negative 2 and x equals 3. So just showing you that all three of those go together, okay? So even on the test, if you are asked to factor it, right, and you get your factor and you get your answers, you could always graph it or use the quadratic formula just to check to make sure you get the same thing. All right, so that's the end of chapter 10, the end of our new material for the semester. So if you have any questions on this, please let me know. Thanks, guys.